Alright, so I'm going to solve a bunch of the problems to help prep you for the Unit 4 celebration. Here we go. So the first part is a bunch of functions, well, 4 functions. And what you want to be able to do is factor them really well so that you can tell all of the key properties of each of the functions. So that takes a little bit of work to make sure they're all factored correctly. So of course, this one here factors well. On the bottom, you'd want to take out the x, and then that leaves you with x minus 3. So that's just taking out the GCF. This one here is one of those nice double bubbles. So remember, this is the little x that we make. So we say two numbers that multiply to be negative 14 and add up to be 5. So after some thought, that would be 7 and negative 2. So that means that's x plus 7 and then x minus 2. On the bottom, you want to think of two numbers that multiply to be negative 10. So that would be two numbers that multiply to be negative 10, and they add up to be 3. So then that would be 5 and negative 2. So then it would be x plus 5 and x minus 2. And then this one here, the bottom, is factorable. And so that's a difference of two perfect squares. So that's x minus 2 times x plus 2. This one, function d, doesn't really factor, so we'll just leave it as it is. Okay, now let's go to some of the questions. So the first one, so I probably on these I'll have to look at my solutions on here and just kind of explain why I thought each answer was what I thought. So like, for example, the first one, the domain, oops, let me go back. So the domain being saying that x can't be negative 2/3, I knew it was function d because this function right here, if you look at the denominator, you can tell that negative 2/3 is what makes the denominator equal 0. And if you can't tell that, what you would do is just set it equal to 0 and then solve for x. Vertical asymptote, x equals 2, that's function c, because when you have this form here and you cancel out the x plus 2's, you can tell that there's still an x minus 2 left over on the bottom. And so 2 is the thing that will cause division by 0, so that gives you a vertical asymptote at x equals 2. The wholes are always achieved by factors that are canceled out, and you can see that the x plus 2 is canceled out, so that means there's a whole at x equals negative 2. Horizontal asymptote, y equals 1, that's if the powers are the same, the degree on the top and the bottom are the same, then it's the little coefficient that's in front. And since this one doesn't have a coefficient in front, we know that it's just 1 over 1, so that means that would be the horizontal asymptote, y equals 1. The wholes would be this function b, whole being x equals 2, because you can tell the factor x minus 2 is canceled out. The next 5, the one that doesn't have any wholes is function d, because there aren't any factors that cancel out, nothing that's canceling from the top and the bottom. The one that has a horizontal asymptote that's y equals 0 is actually two different functions, a and c. And that happens whenever the degree of the denominator is larger than the degree of the numerator. The domain saying that x can't be 2 or negative 5, that's function b, because when you look at it, you can tell that that's what causes the denominator to equal 0, is 2 and negative 5 right here. So that means that's a part not going to be part of the domain, so it's all the x's except for those numbers. And then the vertical asymptote, x equals 3, function a, because when you cancel out the x's, you can tell there's still an x minus 3 on the bottom, so that means there's a vertical asymptote there. And then this j one, the domain that can't be 2 or negative 2, you can tell it's function c, because it has the x minus 2 and the x plus 2 on the bottom, and that causes division by 0, so you can't have that, so that's why that's the correct one. All right, describe in words. You can tell this one here has an x minus 1, and you can tell that's what makes it go right 1 unit. And then it has the plus 8, so that means it goes up 8 units. Then if you wanted to graph this, what you would do is you can tell that it shifts to the right 3 units. So we go 1, 2, 3, and that's exactly where your vertical asymptote is. And that makes sense because before, whatever causes division by 0 on the bottom, that's where the vertical asymptote is. So that's x equals 3. And then the horizontal asymptote is going to be 2. So it's just whatever is added or subtracted there. So it's up 2 units. So horizontal asymptote, that's y equals 2. And then the way this graph works is it's always going to be down in this area here. And then it's going to be in this area here if it's not reflected. So, and again, you can just plug that into the calculator and see exactly what this graph looks like. All right, another one of these is very similar. The x plus 5 shifts the graph 5 units to the left. So we go 1, 2, 3, 4, 5. Nice dotted line there. And then the horizontal asymptote is 4 units up. So go up 4. And then normally the graph is down here and here, but because of this -1, it's not going to be in those 2 spots. So it's going to be reflected over the x-axis. So instead it's going to be here, and it's going to be here. Okay, and again, the graph approaches the asymptotes. This one, really just have to look at the graph and state, what you see there. So the vertical asymptote is right here. It's right at 2, so x equals 2. And then the horizontal asymptote, so that's vertical. And then the horizontal is also, we're just staring at it right here, so that's y equals 1. So that's the horizontal asymptote. And then the whole is right there, open circle. You can tell that it's at the coordinates 3, 2. Okay, now we change gears. We're going to start simplifying a little bit. So these work really well to factor everything, and then if it's division, you just have to flip the one on the right and make it multiplication. So top left, this top left one, it factors 2 parentheses x plus 5. The bottom left one factors, take out a 6, and then it would be x minus 7. It's going to be multiplication, and then you always have to flip the one on the right. So flip one on right side, the one that's right after the division symbol. Then we're going to factor as well. So we take out the 4, and then it would be x minus 7, and this x plus 5 becomes the denominator. So now we just start canceling. So we're just going to slice away here. So this is the battle. So x minus 7 cancels with x minus 7. And then whoever the survivors are, we just multiply straight across. So 2 times 4, that would be 8. 6 is the only thing left on the bottom. So then we can reduce the fraction, so 4/3. Okay, next one, we just want to factor it well first. So let's say the top left one here is a double bubble. So again, 2 numbers that multiply to be 16. If you have to make your little x each time, go ahead and do that. So 2 numbers that multiply to be 16 and add up to be 8. So that's going to be 4 and 4. So this would be x plus 4, x plus 4. This is x squared times. And now we're going to take out the greatest common factor, which is x, and that would leave you with x minus 3. Bottom right, double bubble, so that's going to be x plus 4, x minus 3. And then we want to start canceling. So x plus 4's cancel out. One of the x minus 3, those x minus 3's cancel out. This is 1x. This cancels with one of the two x's. That still leaves you with an x left over on the bottom. And now you multiply straight across, and it would be x plus 4 over x. Okay, now we're going to be adding and subtracting some fractions, some rational expressions. So we have to figure out what the least common denominator should be. So because these are very different, one's x minus 3, one's x plus 3, the least common denominator is just the two put together. So the one on the left is missing an x plus 3, so you have to multiply top and bottom by x plus 3. And then the one on the right is missing an x minus 3, so you just multiply top and bottom by x minus 3. Then we're going to distribute this, and they both have the same denominator now, so I'll just write that denominator again. So this will be 2x plus 6 plus, and then this gets multiplied, distributed, so that would be x squared minus 3x. And then it has that same denominator, x plus 3, x minus 3. So now the two fractions have the same denominator, so now we can actually combine the numerators. So you just kind of combine like terms. So x squared doesn't have anything, so you just put that first. Then 2x minus 3x, so that would be minus x, and then plus the 6. And then you just keep that same denominator, x plus 3, x minus 3. All right, next one, the LCD. Tough to tell right now. You got to factor the bottom left one. So this one factors x minus 5, x plus 4. Again, do your little x if you need to figure that out. But that's what the least common denominator should be. So the least common denominator is the two of those put together. So x minus 5 times x plus 4. So that means the one on the left is already in good shape. So I'll just write that one again. X minus 5 times x plus 4 minus, and then this one is missing the x plus 4, so I'll go ahead and put that top and bottom. Then we're going to distribute this. So I'll just do a little minus sign in the middle, and I'll distribute this. So that would be 2x plus 8. And then on the bottom, it now has the same denominator, so it's going to be x minus 5 times x plus 4. Now, if you look at these two fractions, they have the same denominator, so now you can combine the numerators. So just make sure you distribute this negative sign. So think of it like this. So x minus 2x would be minus x, and then minus 8, that would be the top. So that's the numerator. And then we keep that same denominator, so x minus 5 times x plus 4. All right, these two, I'm going to go ahead and say they're different denominators. So I'm going to say the least common denominator is just putting the two together again. So 2x plus 4 times 2x minus 3. So that means the one on the left needs 2x minus 3. Let's see if that lets me write here. Oh. This one needs 2x minus 3. And the other one needs 2x plus 4 because they're different. Okay, so the bottom of this one should be 2x plus 4 times 2x minus 3. And then now I can distribute the numerator. So that would be 12x minus 18 minus. And then this one's going to have that same denominator, 2x minus 3, 2x plus 4. And the numerator is just going to be 2x plus 4. Now these two fractions, they have the same denominator, so I can write that. 2x minus 3, 2x plus 4. And now I can combine the numerators. So just have to make sure you remember the negative sign gets distributed. So that's 10x, and then it's minus 18 minus 4, so that's minus 22. All right, next one. Now we get into solving equations. So if it's a proportion, which means that one fraction equals another fraction, then we cross multiply. So this would be 3 parentheses 3x plus 2 equals 4 parentheses x minus 1. We're going to distribute the 3, so that would be 9x plus 6. And then we distribute the 4, so that would be 4x minus 4. We're going to solve for x, so probably a good idea to subtract 4x from each side. So minus 4x, minus 4x. That would be 5x plus 6 equals negative 4. Next, it'd be a good idea to subtract 6, so that would be 5x equals negative 10. And then go ahead and divide by 5. So divide by 5, we get x equals negative 2. Just make sure that we're allowed to have that as an answer, because the answers that we're not allowed to have would be x can't be 1, and x can't be, and what we'd have to do is set this equal to 0 to make sure. But if we set that equal to 0, a little mental math, that would be negative 2/3. So x can't be negative 2/3. All right, now a little bit harder equation. When you have one like this, it's an amazing idea to multiply by the LCD. So figure out what the least common denominator should be. If you have an x and an x plus 1, then the least common denominator should be just those two put together. So it should be x times x plus 1. Now multiply every part, every fraction, every part of this whole equation by x times x plus 1. So x times x plus 1. We'll do it here as well. X times x plus 1. And then we do it here as well. X times x plus 1. Okay, so now we're going to start canceling. The reason why we multiply by the least common denominator on both sides is because it gets rid of all the fractions. So it gets rid of these denominators. So this x will cancel with that x, and that's going to leave us with 4 parentheses x plus 1 minus. Then this x plus 1 will cancel with the x plus 1 that's right above it. So then that'll leave us with 3x. And then this here will just distribute. So this will be x squared and then plus x. And of course the 1 doesn't do anything. All right, so we're still finishing this out. So we got 4x plus 4 minus 3x equals x squared plus x. So on this side, we can just combine those. So 4x minus 3x, that's just x, plus 4 equals x squared plus x. Okay, now we notice that we have an x on both sides, so we can subtract x. That would cancel out. So then we'd have x squared equals 4. And then if you take the square root of both sides, that would be plus and minus 2. And then we just make sure that that's a valid answer. So this one here, x can't be 0. And this one here, x can't be negative 1. So neither one of those are a problem for us. So we're just going to say plus and minus 2. All right, this one, we probably want to factor the bottom right one. So this would be x and then x minus 1. Good news, that's exactly what these two factors are. So the least common denominator will be x times x minus 1. So we're going to multiply everything by that. So this gets x times x minus 1. This gets x times, it's not letting me write, times x, alright, carabumba. Come on, you little rascal. Not letting me write. There we go. Okay, this one gets x times x minus 1. So all of them get that. Okay, now we're going to see what happens. So on the first side here on the left, the x will cancel out. So then it'll be 2 parentheses x minus 1 plus, not plus. Then the x minus 1 cancels out, so then that'll leave us with 6x. And then here, the x minus 1 and the x cancels out, and it's just a 6 left over. Much better. So then we're going to distribute this, so we're going to get 2x minus 2 plus 6x equals 6. 2x plus 6x, that's 8x. And then we're going to add the 2 over, so that would be 8. And then divide by 8, so that would be x equals 1. Now we need to look at this and see. This says that x can't be 0. And this says that x can't be 1. Oops, that's what we got. We got 1. So we cancel that out. We pretty much say that this is a extraneous solution. So we're going to have to say no solution on this problem. So no solution is the final answer. All right, let's see what I got. All right, so now we're going to work backwards a little bit and figure out the equation or a possible function. Okay, so y equals, yeah, I didn't want green. Hold on a second. I got an email that messed up my screen. Okay. All right, so I got y equals, all right, if you ever have a vertical asymptote like x equals -4, then the factor that's associated with that is x plus 4, and that's going to go on the bottom. This one doesn't have any holes, so we're not going to have any extra factors to put in there. And then this has a horizontal asymptote that's y equals 0. The way that that happens is when the degree of the denominator is greater than the degree of the numerator. So basically the powers of x are greater on the bottom. So we could just put a 1 on top, and that actually would do the trick. So this would be an okay answer. The next one, we would say y equals, it has a vertical asymptote of x equals 2, so then we could put a little factor x minus 2 on the bottom. It has a hole at x equals 5, so that means we could put a little x minus 5 on the top and the bottom. Because if we slice that out, then that would show that there's a hole at x equals 5. This one says it doesn't have any horizontal asymptotes, and the way that that happens is whenever the degree of the numerator is actually bigger than the degree of the denominator. So right now, the degree of the numerator is not bigger. That's x to the first power. This would be x to the second power, because this is a 1 and a 1, and that would make x squared. So we need to make sure we have enough x's on the top so that there's actually more x's, more higher degree on the top. So if we do x squared, that would do the trick, because then it wouldn't have any horizontal asymptotes. Next one, y equals, x equals 1, so that means x minus 1 would have to be on the bottom. The hole at x equals -10 means that the factor would be x plus 10, top and bottom, x plus 10. And then the horizontal asymptote happens when, at least to 7/8, whenever the degree is the same on the top and the bottom, then there has to be a little 7 and a little 8, like out in front. And we'd look at those coefficients. But right now, the degrees aren't the same because this bottom has 2 different x's, x times x, which would be x squared if you multiplied it out. This one only has an x, so then we have to also put a little extra x in there, because then it would be x squared, and then it would be 7/8, which is what would give us this horizontal asymptote. Okay, so now the application type problems. So the good news is that the structure is on the celebration. So if we, let me write that, it says the structure is time together over time alone, and then plus time together over time alone, and then equals 1. So, pretty easy. Let's see. So, but this has 3 fractions, so same. So it's going to be time together. Let's see, where is the time together? We don't know what the time together is. So we're going to say that's x. So this would be x. And then the time alone, one of the students, it was in 5 days. So that's 5. The next student could do it in 3 days. So that's x over 3. The next student could do it in 4 days. So that's x over 4. And then equals 1. So they're able to complete one job, which is completing the prom decorations. Okay, to solve this, we multiply by the least common denominator. So it's whatever number basically all of these go into evenly. You could call it a least common multiple as well in this case. So 5 times 3 times 4 would do it. So that would be 60. Is that the lowest one I can think of that all those numbers go into? I think that would probably work. So we're going to multiply everything by 60. So I usually put 60. I put 60 just like we've been doing. I put it next to everything. So 60 next to everything. So now I just see how they cancel. So 5 goes into 60 12 times. So that's 12x. 3 goes into 60 20 times. 4 goes into 60 15 times. And then 60 times 1. Now we add all those x's, so that is 35, 47, so 47x equals 60. X equals, and that's going to be 60 divided by 47. And that's days, or about, 1 point whatever days. So 60 divided by 47, let's say 1.3 days, rounded to the nearest tenth. All right, let's see, last one. So tidy mains. Okay, so we got Liam and Zach. All right, so we got Liam, we got Zach. All right, so time together on the top, time alone on the bottom. Okay, Liam, where's he at? Liam, he can do it 7 hours by himself. That goes on the bottom. Zach, how long does it take Zach to do it by himself? We don't know, so that's x. Together, so it says when he works with Zach, it takes him 5 hours. So together, it's 5. So that's why that 5 is on top. As far as solving this, it's the same as the other one. So the LCD is 7 times x, or just 7x. So we multiply 7x by everything. 7x next to everything. So let's look to see what cancels out. So 7 cancels with the 7, and that would be 5x. The x cancels out. That would be 5 times 7, so that would be 35. And then equals 7x. So we solve this equation. We're going to subtract 5x. So that would make this 2x equals 35. Again, if you need to show your work there, minus 5x, minus 5x. Okay, so then we're going to divide by 2. So we're going to say x equals, and this would be 35 divided by 2, which is, let's see, 35 divided by 2, 17.5. Holy moly. Takes Zach 17.5 hours by himself. He's slowpoke. Okay. Makes sense? Let's see. I think that is it. Good luck.